welcome to another tutorial. My name is tanmay bakshi, and this time we're going to be going over how you can use the IBM Watson visual recognition service in order to classify the audiology dataset that I showed you in my last healthcare audiology video. So let's get right into that. Now in my last video, what I showed you is how you can take the audiology dataset from the UCI machine learning repository. And what I did is I normalized that data and provided it for you in the description of the last video. And in the last video, what happened is I took that data, which consisted of around 200 rows of 69 input values and 3 output values. So we've got 69 inputs and 3 outputs in that data set. And so what I did is I actually had a shallow neural network that I created. And what we did is we fed in those 69 attributes. And we trained this neural network to literally learn that audiology data set. And what happened is our neural network gave us 3 outputs at the end. And these outputs actually corresponded to each one to a different type of hearing disorder. And what happened is these outputs gave us the probability values of the person that these attributes are describing to have one of these hearing disorders. The first one is just, he has a normal ear. So the first one is normal. The second one means that he has a hearing problem due to cochlear age. And the third one is due to a cochlear anomaly. We don't exactly know what's wrong with his cochlea, but it's something to do with the cochlea. Oops. Okay, so that's basically what we fed into our neural network, and that's what our neural network gave us as output. We would feed in around 69 attributes of a person, and then it would output 3 different probability values for 2 different types of hearing disorders and 1 probability for a normal ear. But I decided that we want to do something a little bit more interesting and something a little bit more easy for beginners. So I wanted to see if IBM Watson can actually understand this data and train on this data. But then I realized that, wait, there's no service on the IBM Bluemix catalog that can understand this numeric data just like my shallow neural network did. So what I did is I went ahead and used the visual recognition service. But if you're wondering how exactly I fed a numeric data set into visual recognition, well, I'm going to tell you in just a moment. But before you continue watching this video, I'd highly recommend you watch my last audiology video where I show you exactly how all of this works. And once you understand that all of that data and exactly how it works, then you can come back to this video and we will continue, and I'll show you how you can use IBM Watson to work with this. Alright, so I'm assuming you've seen that video, and by the way, a link to it will be down in the description below, but now let me tell you how this is going to work. Now, since IBM Watson cannot understand numeric data, we have to have a way to convert whatever Watson's taking in from this numeric data to something it understands. And a way that we can easily convert this numeric data to something it understands is quite simple. A visual piece of data. Let me show you. So basically what I've gone ahead and done is I've converted this numeric data set into a visual data set. So let me give you an example that doesn't rely on audiology. Now let's just say we've generally got 6 different inputs for a neural network, 6 lines. And so let's just say this is 0.2, 0.3, 1, 0, -1, 0.5. Okay, this is all of our data, randomly generated. Now before, instead of sending this to a neural network and having to, engineer that neural network and optimize it to the core, all we need to do is feed it into Watson. But there's no way we can just directly feed this into Watson. This does not work. Oops, sorry, Watson. This will not work in this case because it's numeric data. So what we have to do is what I've done is I've actually created a script in the Swift programming language. And what it'll do is it'll take all this data and it'll run it through that script. Okay, so what's going to happen is all of this data is going to go into that script over here. And once the script has that data, it's going to convert it into a visual representation of that data. The script is then going to convert that to the image. And then this image is then sent over to the IBM Watson Visual Recognition Service, where it can then be processed. And once it is processed, and once visual recognition knows exactly the distinction between that data and has understood this data, we are then ready to get our output. And visual recognition, once it's done training on a few hundred images, will give us our output values. And technically, we actually have, again, 3 different output values. Again, for normal ear, we've got one for the normal ear. We've got one for cochlear age, and one for a cochlear anomaly. When we know it's something to do with the cochlea, but we're not exactly sure what's wrong with your cochlea. So now in this video, that's exactly what I'm going to be showing you how to do. How to convert this numeric data set into a visual data set with all of its rows. And then visual recognition will train on it, and then we will feed it a new image which represents another row in the test data instead of the training data. And then we will finally be able to take that data, feed it into visual recognition, and see if it has a reasonable accuracy for us to actually work with it, and then compare it with our actual neural network. Alright, so now let's get to the coding part, where I'm going to show you how you can implement all of this. Let's get to it. Alright, so welcome back to the Mac part, and now I'm going to be showing you how exactly we can actually implement this application. So let's take a look at the Swift script to begin with. Now, as you know, the first part of the job is to take our numeric CSV data and, of course, visualize it and basically represent it in a visual way. And the way we can do that is using this script that I've created. Now, of course, the first little part over here, these first few lines, these are actually from the human-friendly blog over here, and they show you how you can take an array of pixel values, pixel data values, and you can actually create a UI image out of those values. And of course, what I've gone ahead and done is I've updated it to Swift 3 to make it work with the latest, of course, Xcode, and I've also made it, instead of working with UI image, to CG image, so that, of course, we can use this with a macOS command line application. Alright, so once that is done, as you can see, there's another function that I have created. Now, this is a function that I've created. This isn't from anywhere online. And so basically, this function is called value to pixel intensity. And as I said in the whiteboard part, basically, we're going to be taking these inputs, and we're going to be converting them to these pixels, and we're going to be putting these pixels together into images. And so the point is that basically, we should be able to take some sort of input, and this input could be anything. It's either going to be a -1 value or a value between 0 and 1. We'll be taking that value, putting it through this function, and the function will return a pixel data value. The way this works is it checks if the value is greater than -1. If it is, then we return a pixel data with the alpha of 255 and the red, green, and blue value set to 255 times the value. What this does is it means, basically, let's just say that your value is 0. Then 255 times 0, that means you're going to have 0 R, G, and B. And this means you're going to have a completely black image, because, of course, there's no color. But if it's a 1, then you're going to have 255. And this means that you're going to have a completely white image, because all the red, green, and blue are 255. However, if your number is something like 0.2, then you'll have something like 51. And so this is going to be, basically, I guess you you could say 20% black and then 20% white, and this would be then 80% black, and so it's a relatively dark color. But if we were to get somewhere like 0.8, now this is 80% white and 20% black, so we're getting basically higher and higher in terms of the whiteness of the image, and lower in terms of the blackness of the image when we increase our value. However, if our value is equal to -1, then we just create a red pixel by setting the red to 255, green and blue to 0, and of course the alpha to 255 as well. Once that is done, we are ready to actually begin the logic that will try and understand our CSV file. So the way we do this is we create a new two-dimensional double array called audio data, which is equal to a blank array to begin with. Now, audio data is actually going to contain every single row of data, basically represented as an array of doubles in this array. And so in order to actually fill this up, though, what we need to do is actually loop through those rows and add them individually to audio data. And the way we can do that is by, first of all, getting the contents of our CSV file. The way we can do this is by creating a new constant called CSV data contents. And what we're doing is we're forcefully trying to get the contents of a URL into this string. And of course, this URL points to my audio data CSV file, which contains the data for my Audiology dataset. Once that is done, I then split up the entire string of contents into multiple strings, an array of strings, and I split this by the new line separator. And so what I do is I put that array into something called the CSV split line constant, and that is exactly how we are able to get these into separate lines. But then what we need to do is we need to loop through CSV split line, and we need to, first of all, inside of this loop, create a new double array, single dimensional double array called audio data line. This is initialized as a blank array to begin with, and what we do is we then loop through I, which is looping through the CSV splitline array, and we split every single line by the commas in that line, in that row. And then what we do is we loop through those that separated value, and for every single value separated by commas, what we do is we check if we can convert that to a double by converting it to a double and then checking if it's nil. If it's not nil, then we put it into a constant called JNumber with the if-let statement. And then what we do is we append JNumber to the audio data line array that we created here. Then at the end, what we do is we append that audio data line to the audio data array, and once that is done, we have our array of arrays, which contains basically an array of the rows in our CSV data. After that, what we do is we remove the last element from that audio data due to the fact that, well, of course, there is a blank line at the end of my data, and of course, we don't exactly want that to show up in our data because that will not be good. We do not want that extra line in our data, so we remove that. You may not need this for your data, but I'd recommend just checking this out, and if you have a blank line at the end of your data, you would want to have this line. Once that's done, I'm just printing out the data to make sure that it's nice and it's been parsed correctly. And once that is done, then of course it's going to loop through the audio data array, and of course it's going to enumerate that audio data array as it does this. And so basically what's going to happen is we are going to get the index and value instead of just the value while we're looping through. Then what we're going to do is we're going to create a new variable called name inside of this array. And the reason we're using the name variable is because, of course, we have to have some naming logic for these images so that we don't have overlapping images with the same names. And of course, we do want to be able to know just from the name of the image what the output of this image should be so that we're able to organize the images correctly so that they get into visual recognition again correctly. And so in order to do this, basically if the output for this is cochlear anomaly, then we set the name, the beginning of the name to 001. If it's cochlear age, then we set it to 010. And if it's a normal ear, then we set it to 100. Once that is done though, we then create a new array called pixels, and this is an array of pixel data values. And once that is initialized, we then loop through the value variable, because remember, audio data is a two-dimensional double array, and we're looping through it. So the value that it gives us during the loop is actually going to be in turn another double array. And so we're able to loop through it, and for every single one of those values, we convert that value to a pixel intensity using the value to pixel intensity function. The result of that function is then appended into pixels, and then we have another function called write CG image. Now the write CG image function will take a CG image as well as a URL to write the image to, and will return whether or not it was able to actually write that image to that file in a Boolean. Now this is actually from Stack Overflow, and there will be a link down in the description below that links to the answer for how you can actually write a CG image. After that, we remove the last 3 pixels, and the reason we remove the last 3 pixels is because, well, of course we do not want our outputs going to visual recognition, because of course there's no point of visual recognition, of course, finding the results if it already knows the output values. Finally though, once that's done, we convert those pixel values to a CG image by calling the image from a RGB 32-bitmap function. And what we do there is we pass it the pixel data array that we created, called pixels. We give it the width value of 23 and the height value of 3. This means basically 23 times 3, and that would be 69 input values going to visual recognition. Now, this is actually the image that we are passing over to write CG image for it to write. But after we pass in the image, then we have to pass it a URL to where to write this image to. Now we are actually getting this URL from a string, and I'm putting this to a specific directory that comes from my home directory. And so what I'm going to do is I'm going to put the naming scheme as the name we decided that's based off of the output that we decided in the beginning, then an underscore here, and then the index of the image in the audio data array, and then .png. And after that, it should be complete, and we should technically have a bunch of images with the outputs in the beginning of them, and of course the final index of that respective image in the audio data array, which corresponds to its row in the CSV file. And from there, we should easily be able to feed these into visual recognition and train them. But what I've gone ahead and done, as you can see in this Finder window, I have gone ahead and created a folder called Final Images, and I split up all of the images into 3 separate folders, one called 001, one called 010, and one called 100. Let's take a look at the cochlear anomaly pictures first, or 001 pictures. As you can see, we've got a good few of these pictures here, and if I just open up one of them, as you can see, these are extremely tiny images. They're only 23 by 23 in terms of dimensions. I have to zoom into them for you to be able to see them. As you can see, that is exactly what our image looks like. It makes absolutely no sense to a human, but to visual recognition, this makes a lot of sense, and it should be able to understand the patterns between cochlear anomaly, cochlear age, and of course, normal ears. Now, if I go back, we can also take a look at our cochlear age photos here. As you can see, we've got a good few photos. But apart from that, we can also look at our normal ear photos, the attributes of people who have normal ears. As you can see, that's exactly what that looks like, and that is what we are going to feed into visual recognition. Now, I do have another video in the works for how you can actually train visual recognition using the Watson Visual Recognition command line tools, or utilities as they like to say, and of course that will be out soon. However, what I've already gone ahead and done is I've trained visual recognition on this data, and so what I've done is I've created a classifier over here called the Audiology classifier, and so what I'm going to do is I'm going to run the Watson Visual Recognition utilities on this classifier. And if we go back to the Finder over here, as you can see, I've actually separated out, before I train visual recognition, I separated out an image called 001_24_test_image.png. Now this is actually, again, a very small image, the same 23 by 3 dimensions, and this actually represents a cochlear anomaly. And what we're going to do is we're going to feed this into visual recognition and see if it can recognize this as a cochlear anomaly with a good amount of accuracy or confidence. So as you can see, what I'm going to do is I'm going to enter in the image's name, which is 00124 test image.png. I'm going to click enter, give it a moment, and as you can see, visual recognition should say in just a moment that this is a cochlear anomaly, or 001, and that too with almost 80% confidence. To be more specific, that would be 79.8424% confidence. And as you can see, that is actually very, very high in terms of confidence, and it got the correct answer. And so of course it was able to correctly classify that this data, this numeric data that we've represented visually, is indeed a cochlear anomaly. It was able to understand that, and that is absolutely amazing. And so of course what I'm going to do here, I'm just going to restart this. Okay. So that worked, and that's what I had to show you in this video today. How you can actually take this numeric CSV data, represent it visually, train visual recognition, and then use visual recognition. Test it out and take a look at it in more detail. There will be more tutorials coming out soon, just like this one today, and of course one more coming out soon about the Watson visual recognition utilities, command line utilities, and how you can use them in order to train, use, and list out classifiers. And of course much more, all coming out soon. Once it's out, the link will be in the description. Apart from that, whatever else promised will also be in the description, as well as the source code of this application. Alright, so thank you very much for joining in today. I really do hope you enjoyed, and in fact, if you did, please do make sure to leave a like down below. Of course though, if you think this video could help anybody else you know, like your friends or family, please do make sure to share the video as well. And of course, if you have any questions, suggestions, or feedback, please do make sure to leave that down in the comment section below. Tweet them to me at tadjimanny, or email them to me at tadjimanny@gmail.com. Of course, my contact info will be down in the description below, but if you really like my content and you want to see more of it, please do make sure to subscribe to my YouTube channel as well, as it really does help out a lot. Of course, though, if you'd like to be notified whenever I release new content, new videos, please do make sure to turn on notifications by clicking the little bell icon beside the subscription box in order to turn on notifications. Alright, so thank you very much for watching today. Goodbye.